All right, yesterday we talked about, well, we finished 4.8, which was your isosceles and equilateral triangles, right? We talked about the base angles theorem, the base angles theorem converse, and then the corollaries, which say if it's equilateral, it's what? Equiangular. If it's equiangular, it's equilateral. Okay, so if you look at these, number one says to find x, or the value of x. What kind of triangle is that? Equiangular. So if it's equiangular, it's equilateral, which means x is what? 8. Number two, what kind of triangle is this? Isosceles, because if those two angles are congruent, then these two sides are congruent. That would be the converse.
So 24 is equal to 7x plus 2.
Good.
X equal 3.
Number 3 says if the measure of the vertex angle of an isosceles triangle is 122, what are the measure of the base angles? So remember, vertex is the non-congruent one, right? So if vertex is 112, this is not drawn to scale, obviously, then the other two would be congruent. So I would do 180 minus 112, and you get what? 68. And then that's both of the angles combined, so I'm going to take 68. Good. Divide it by 4. Well, divide it by 2, and I get 34 degrees for each of the other two. And be careful, because if it had said, like, what's like one of the base angles, it couldn't have said 112, but if it had said one of the base angles is 34, what are the other two angles? You'd have to know that the base angle is the one that happens twice. So it would be 34, 34, and then you'd find the other one, which would have been 112. Okay, and then number 4 says find the perimeter of the triangle. What kind of triangle is this? It's equiangular, so if it's equiangular, it's equilateral, which means if I had grabbed any of those two of 3 and set them equal to each other, I should have been able to solve for x. So if I did x plus 13 equals 2x plus 4, subtract the x, subtract the 4, I get x equals 9. If I had done these two,
72 x.
good.
And then just times whatever you get by 3, and you get the perimeter, right?
Yep. Either way, like if you, and you could have picked these two. They all would have given you x equals 9. And then it says, what's the perimeter? The perimeter, we add up all the sides. So in order to find out one of the sides, I just take that 9 and plug it in. I'd get one side is 9 plus 13, or 22. And there's 3 of those.
So 66.
Good. And it gave you a unit this time, 66 centimeters.
You know what? Sorry, I took off my glasses for a second and didn't see.
Okay, so we're going to work through these, right? So this is the proof practice. This one says that line PR, which is here, bisects QPS, so it bisects this angle here, and that line PQ is congruent to PS. So that's all part of my given. PR bisects angle QPS, and PQ is equal to PS. I don't mind you drawing arrows for practice, but on your test, you need to make sure you rewrite out your given. Don't be lazy. Okay, so based on just that information, what can I determine from the given? What piece of information does it give you that you can use?
QPR is congruent to SPR.
QPR is congruent to SPR, which is also what numbers?
1 and 2.
1 and 2. Okay, so angle 1 is congruent to angle 2. You could use either one. And that's the definition of an angle bisector. Then what?
Angle bisector or just bisector?
Better answer angle bisector, because it actually says it bisects the angle. I don't know if I'd mark it wrong if you just put bisector though. Lewis.
You have the reflexive side.
Good, you've got the reflexive side. So if you can't figure anything else out, look for the obvious stuff like the reflexive side, like vertical angles, that kind of stuff. So PR is congruent to PR, and that's reflexive. Now, are these two triangles equal to each other?
Yes.
And how?
Side.
Side.
Good. So I could say QPR is congruent to SPR. And my reason, I don't know why I skipped a number. That should be number 4.
Side angles.
Is side angle side. So then if they are congruent, what's true about all of their corresponding parts?
All congruent.
They're also congruent. So if I'm trying to show that PR bisects QRS, I would need to show that 3 is congruent to 4. So that's the next step. Angle 3 is congruent to angle 4, and this is true because of CPCTC. So then PR bisects angle QRS, Good.
So if it has numbers, you can say the numbers.
Sure.
Yeah.
So why are you proving it again instead of bisecting?
It's a different angle. So it gave you the angle on the left. You have to prove that it bisects the one on the right.
Isn't step 5 like already proving right there?
So if you don't know what the word angle bisector means, then you have no idea what that is. It's because you know what angle bisector means that you know that if the two angles are congruent, then they're equal. Then it bisects it. So you have to use that theorem. All right, given on proof 2 says angle 1 is congruent to angle 5 and 3 is congruent to angle 6. Okay, all of that, again, the given, you're going to write it out because you're not lazy. You are lazy, but you're not going to be lazy on your test. What else is there? Obviously, I got nothing with 1 and 5 and 3 and 6, but what does my diagram show me?
Segment AC equals very congruent to AC, less reflexive.
Are those triangles now congruent?
Yes.
Yes, A, B, C is congruent to triangle CDA. Why? Angle, side. Now, please tell me most of you got that one right. Okay, good.
I got it right.
Okay.
Yeah, I made it longer.
All right, 3. You have. All right, given segment GH bisects GJH and angle J is congruent to H. What else do you see that you're going to write because you're smart? GI equals GI, reflexive. What else did they give you you can use? So this would be congruent to this.
I made it longer.
Are the triangles congruent?
Yes.
Why?
Angle, side.
Wait, and then you see the and then you bring it
Angle JIG. There's no way Brandon equal to GIH.
So then this one, good. Bye guys.
Angle bisector's definition.
You just can.
So you actually, on this one, you could have gone from here. Wait, no. Once you said the angles are congruent, these two, like you could have from here, you could have said CPCTC, or you could have said third angles.
On number 5.
6. Oh, yeah. 5 could have been third angles theorem. That would have worked too, yeah.
I'm gonna have to.
Okay, this last proof says D is the midpoint of segment TN. And D is the midpoint of segment SA. Those are your givens. What you can determine from the picture is that there's vertical angles. So angle SDT is congruent to angle ADN, and that's the vertical angles theorem, or VAT. Now from your given, you know that D is the midpoint of TN, which means TD is congruent to DN, and SD is congruent to DA. Because they have the same reason, you can list them in the same step, and that reason is the definition of a midpoint. Now I have two triangles that are congruent, so I can say SDT is congruent to triangle AND, and that reason is side angle side. Now, if I had, obviously, if that was my proof statement, I'd stop there, but it wants me to continue to state that ST is parallel to NA. So if you remember your parallel proof, it was either alternate interior, alternate exterior, same side interior, or consecutive interior, and corresponding. So if I were to use CPCT to identify all the pair of corresponding angles in this diagram, you would know that obviously the vertical angles are marked, and then angle S would match angle A, angle T would match angle N. So if you look at this as though it's the transversal and these as though they're the parallel lines, it actually doesn't matter which ones you pick. You can either say T is congruent to N, and those would be alternate interiors based on this transversal, or you can say S is congruent to A based on the other transversal. So you can choose either step there. 5 could either be angle S is congruent to angle A, or angle T is congruent to angle N, and the reason is CPCTC. And then from there, we could state that the lines are parallel. ST is parallel to NA, and it is the alternate interior angles. Theorem converse. All right, so that wraps up the proof practice. Make sure you're taking advantage of the chapter review with the solutions and the chapter test that's also on that same assignment. Both the solutions are posted. Remember, your test is more than proofs. It's a big focus, but it's definitely more. Good luck.